Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, where we are going to study some examples based on combination also. With this, we will conclude today's chapter. It is permutation and combination. So, the first example of this today's lecture is example 1. Find the number of ways. Find the number of ways of selecting 9 balls from 6 red balls. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls and 5 blue balls. If each selection consists of 3 balls of each color, right? So the question is number of ways we have to find here by selecting 9 balls from 6 red and 5 white and 5 blue balls if each selection consists of 3 balls of each color, right? Let's see. Here the logic is a simple logic is a solution. There are 6 C3, right, ways of choosing red balls. Choosing red balls and 5C3 ways of choosing white balls and 5C3, that is 5 combination 3 ways for choosing blue balls, right? Because why we are taking here 6C3, because 6 red balls are there but the selection consists of 3 balls of each color. They are saying 3 balls should be there. So 6C3 for red balls, 5C3 for white balls and 5C3 for blue balls. So the total number of ways here, total number of ways is equals to 6C3 into 5C3 into 5C3, right? So now calculate this with respect to combination formula. What we get here, 6 factorial upon 6 minus 3 factorial into 3 factorial into 5 factorial upon 5 minus 3 factorial into 3 factorial, 5 factorial upon 5 minus 3 factorial into 3 factorial. So which is equals to 6 factorial upon 3 factorial into 3 factorial, 5 factorial upon 2 factorial into 3 factorial, again 5 factorial upon 2 factorial into 3 factorial. So now simplify this. What we get here, let's see. 6, 5, 4, 3 factorial upon 3 factorial into 3 into 2 into 5, 4, 3 factorial upon 2 into 3 factorial, 5, 4, 3 factorial upon 2 into 3 factorial, right? So here, which is equals to 3 factorial get cancelled, 3 ones are 3 twos are 2 2 get cancelled, 5 fours are 20 into here 3 factorial get cancelled, 2 ones are 2 twos are 5 twos are 10, right? So again 3 factorial 2 ones are 2 twos are to 5 twos are 10, right? So totally what we get here, 20 into 10 into 10, 10 tens are 100, 100 200 are 20 into 10 is 200, 200 tens are 2000 it is. So the total number of ways of selecting 9 balls from 6 red balls and 5 white balls and 5 blue balls is nothing but 2000 if each selection consists of 3 balls of each color, right? So next example, it is example 2. Determine the number of 5 card combinations 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination, right? Let's see its solution. So before going to solve this example, first we have to understand a 52 deck of cards first, right? Total 52 deck of cards are there here, and that 4 sets are there totally. 13, 13, 4 sets are there. In 13, 13, in each 13 group, what we get? A king, a queen, a joker, and the serial number 10 to 2 and ace, right? Similarly, here also same, here also same, here also same, right? Total 52 decks. We include 4 set of king, 4 set of queen, 4 set of joker, and the numbers from 10 to 2 and ace as well as, right? So the question is here, determine the number of 5 card combination out of a deck of 52 cards if there is exactly one ace in each combination they are asking. What we have to determine here, 5 card combination out of 52 deck of cards, right? So let's see the solution. So here total ace are 4, right? Ace are 4 and non-ace are 48, right? Non-ace means these remaining, these are nothing but non-ace, it is ace, right? So ace is 1 here, it is 4 non-ace. Total 5 cards we have to find out where one ace should be there. Exactly one ace means out of 5 one is ace and 4 are non-ace. In total what we have total in 52 decks, 48 non-ace and 4 are the ace, right? In a 4 set of cards, it is in a deck. Now we have to choose one from 4 ace, right? Total there are 4 aces are there, and 4 non-ace from 48 non-aces, right? So now number of ways which is equals to 4c1 into 48c4, right? So 4c1 is what here? 4c1 is, substitute here directly, what we get? 4 factorial upon 4 minus 1 factorial into 1 factorial into 48 factorial upon 48 minus 48 minus 4 factorial into 4 factorial, right? So here 4 factorial upon 3 factorial, 1 factorial is 1 only neglected. 48 factorial upon 44 factorial upon 4 factorial, right? So now 4 factorial can be written as, which is equals to, that is 4 into 3 factorial upon 3 factorial into 48, 47, 46, 45, 44 factorial upon 44 factorial into 4 factorial. So which is equals to, after simplifying, what we get here, this term becomes what? It is 4 only. 3 get cancelled, 44 get cancelled. If this term can be written as 4, 3, 2, 1, right? So if you divide, goes on dividing this term here 4, and this term, if you simplify, what we get, let's see. After simplifying, we will write total answer here. If you divide this one, 2 ones are, or you can take 4 ones are 4 12s are, right? This goes cancelled. So 2 ones are 2 6s are. So which is equals to 6, 47, 46, 45, right? So now multiplying this, what we get here? Total 7 lakh 78,320 ways, right? It is our required number of ways we can choose the 5 let cards combination out of a deck of 52 cards if there are exactly one ace in each combination, right? So the next example is example 3. Let's see. Example 3. In how many ways in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers, right? So the question is, in how many ways can one select a cricket team of 11 from 17 players? Total we have 17 players, out of which we have to select 11 members, 17 players in which only 5 players can bowl. If each cricket team of 11 must include exactly 4 bowlers, right? So in how many ways we can select a team? Let's see. Solution: 4 bowlers, 4 bowlers can be selected from 5 bowlers. Already we have 5 bowlers out of 17. So in that we can choose 5 bowlers out of 4. 4 bowlers we can choose out of 5 bowlers in 5C4 ways, right? So 7 players are yet to be selected. Still 7 players we have to select from 12 players, right? So they can be selected, they can be selected in 12C7. So total number of ways is 5C4 into 12C7, which is equals to 5 factorial upon 4 factorial into 1 factorial into 12 factorial upon 5 factorial into 7 factorial. Just we have subtracted directly here. 5 minus 4 is 1 and 4 factorial, and 12 minus 7 is 5 factorial into 7 factorial, right? So after simplifying, what we get here? 3960 is the required ways of selecting a cricket team out of 17 players, 11 player in which 4 bowlers include in that team. So this much is in this lecture series. In the next class we will see some more different concepts and different chapter. Till then, take care, stay at home, stay safe. Thank you.